Hello! We will look at the core of a cooperative game. This deals with the stability of the game. We imagine that an outsider has imposed a coalition structure and a payoff vector onto the players. Given such an outcome, what would be a reason that players want to deviate from it? One good reason is that a group of players could generate more value than what they are receiving. So x of c is less than v of c. Then they would much rather form their own coalition instead. But if such a situation does not happen, then we have a stable solution. This is what we call the core, and here is the definition. The core of a cooperative game NV consists of all outcomes pi x such that x of c is at least v of c for all c a subset of n. This means that for any coalition C, the payoffs received by the members of the coalition is at least the value that could be generated by the coalition. In the example of the ice cream game, let's consider the outcome pi x, with pi being the partition of AB in one coalition and C in the other, and the payoffs are XA is a half, XB is a half, and XC is 0. You can check that this is a valid outcome. But is this a stable outcome? And the answer is no. If C joins with A and B, then they will produce a value of 2. Well, currently, their combined payoffs is 1. So it is better if they form the grand coalition ABC, and our given outcome is not in the core. We can use the same reasoning to give us that pi must be the grand coalition if pi x is in the core. But just having the grand coalition as the coalition structure is not enough. If the payoff vector is, say, xa is 2 and xb and xc are 0, then this is also not a stable outcome. B and C could get more value if they break away from the grand coalition and form their own coalition instead. But if the payoff vector is xa is 0 and xb and c are both 1, then this is in the core. We can check that they satisfy these inequalities, which have the form x of c is greater than or equal to v of c for each c. In fact, any valid outcome with a grand coalition where the x satisfies these inequalities would be in the core. We now look at two basic properties of the outcomes that are in the core. First, they are efficient within the coalition structure. Here is the proposition. If pi x is in the core, then x of c is equal to v of c for each coalition C in the coalition structure pi. The proof of this is pretty short, so take a few moments to see if you can prove this yourself. For our proof, we let C be a coalition that is formed in pi. By the definition of the core, x of c is greater than or equal to v of c. But since pi x is a valid outcome, x of c is also less than or equal to v of c. Therefore, x of c is equal to v of c for all the coalitions in pi. And that is our proof. The second property is that the coalition structure generates the maximum amount of total value among all the outcomes of the game. This is called social welfare. We will use this notation. V of pi is the sum of the values of the coalitions that are in the coalition structure pi. So here is our proposition. If pi x is in the core, then v of pi is at least v of pi prime for all the partitions pi prime of the player's n. So the value of pi is the maximum possible. Our proof is a series of equalities and inequalities. We start with v of pi, which is the sum of all the values of the coalitions inside pi. Our previous proposition tells us that the outcome is efficient within the coalitions of pi. So this is equal to the sum of x of c for all possible c in pi. Now this sum is just the sum over all the possible x values for all the players. That's because pi is a partition of n. And because pi prime is also a partition of n, we can rewrite this as the sum of x of c prime for any coalition c prime in pi prime. And now we can use the fact that pi x is in the core to say that this is greater than or equal to the sum of the values of c prime for any c prime in pi prime. And that is just the definition of v of pi prime. So the value of pi is greater than or equal to the value of any partition pi prime, and that is the proof. Note that this proposition only says that coalition structures that maximize total value are eligible to be in the core. But it does not mean that there exists an outcome in the core with this coalition structure. In fact, there are games that have empty cores, meaning they don't have any stable solutions. For example, consider this 3-player majority game. There are 3 players, 1, 2, 3, and the value of a coalition is 1 when the coalition has size at least 2. Otherwise, the value is 0. We claim that no outcome is in the core. We assume otherwise and suppose that pi x is in the core. Then, using the conditions for the core, we have these inequalities. x1 plus x2 plus x3 is at least 1, and all variables are at least 0. So xi must be at least 1/3 for some I. Now the value of any coalition is at most 1, so x1 plus x2 plus x3 is at most 1 as well. This means that x of n minus I is at most 2/3. But the value of n minus I is 1 because there are 2 members in this coalition. And this is greater than x of n minus I, the values received by these 2 players, which we know is at most 2/3. So this contradicts the assumption that pi x is in the core. So therefore, the core is empty. So now one of the main questions in cooperative game theory is, which games have non-empty cores? This is not an easy question, and in fact, in general, it is very difficult to determine whether or not a game has an empty core. But we will look at some of the results regarding this in the next few lectures.